Something terrifying happened in the summer of 2025, and NASA doesn't want you to know about it. On July 21st, the most powerful space telescopes on Earth locked onto an interstellar visitor unlike anything we'd ever seen. For weeks, extraordinary data poured in. A massive green glowing coma stretching over 300,000 kilometers across space. Strange chemical signatures that defied explanation. A mysterious brightening that had scientists scrambling for answers. Then, just as things got interesting, everything went silent. No more Hubble images. No fresh data from the James Webb Space Telescope. The steady stream of discoveries that had captivated the scientific world suddenly dried up, leaving behind only cryptic technical explanations and a growing list of unanswered questions. The object in question? Comet 3I Atlas, the third confirmed interstellar visitor to enter our solar system, and possibly the most enigmatic one yet. But here's where things get really strange. While NASA claimed their silence was due to routine technical constraints, amateur astronomers worldwide kept watching. What they saw defied every explanation the space agency had offered. The comet continued to evolve, developing new features that shouldn't exist. Its brightness scattered wildly from night to night, sometimes changing by more than a full magnitude. Reports of that eerie green tint persisted, growing stronger rather than fading. The timing of NASA's Blackout wasn't just suspicious, it was perfectly orchestrated. Just as 3I Atlas reached its most active phase, just as the most sensitive instruments in human history were positioned to uncover its secrets, the flow of information stopped. Official channels went dark, press releases disappeared, even the routine technical updates that usually keep the scientific community informed vanished without explanation. What makes this silence even more disturbing is the contrast with previous interstellar visitors. When Oumuamua streaked through our solar system in 2017, data flooded out almost immediately. Scientists published preprints within days, sparking open debates and wild speculation across the internet. Borisov in 2019 followed a predictable pattern with images and spectra released on schedule. But 3I Atlas, the moment it became truly interesting, the curtain fell. Something about this particular visitor has NASA worried enough to break their own protocols. The question isn't just what they found, but why they're so desperate to keep it secret. And with each passing day of silence, the theories grow darker and more disturbing. Before NASA's information lockdown, the data they released painted a picture of something that shouldn't exist. The Hubble Space Telescope's July images revealed a comet unlike any in recorded history. Its nucleus, barely 5.6 kilometers across, was generating a coma that dwarfed most known comets at similar distances. We're talking about a dust and gas envelope stretching nearly 350,000 kilometers, more than a quarter of the Sun's diameter. But size wasn't the most disturbing discovery. The chemical composition readings that leaked from early spectroscopic analysis suggested something unprecedented, a carbon dioxide-dominated coma. Now here's why that's terrifying. Most local comets at this distance from the Sun are water-dominated. Carbon dioxide signatures this strong typically indicate a comet that's never been heated by a star before, a pristine remnant from the depths of interstellar space. The implications hit the scientific community like a freight train. If 3I Atlas truly had never encountered stellar radiation, it represented a time capsule from the formation of alien solar systems. The chemical signatures locked within its ice could reveal the conditions around distant stars billions of years ago. But there was something else hidden in those early reports, something that made NASA nervous enough to clamp down on further releases. Amateur astronomers provided the missing pieces of the puzzle. Multiple observers reported that distinct greenish tint, likely from dicarbon or cyanogen molecules, but with an intensity that defied explanation. The green wasn't just present, it was persistent and bright, far more so than typical comets. Some seasoned comet watchers described it as the most vivid green coloration they'd ever witnessed. The sunward plume captured by both Hubble and Gemini telescopes added another layer of mystery. This wasn't behaving like normal comet material. The shape and brightness seemed to shift dramatically from night to night, suggesting either rapid surface changes or something more disturbing, controlled outgassing. When comet material behaves this erratically, it raises questions about what's driving the activity. Even more concerning were the photometry measurements, the precise brightness readings that help scientists understand a comet's behavior. Professional and amateur observations scattered wildly, sometimes differing by more than a full magnitude on the same night. This level of variation suggested either rapid internal changes or something actively modulating the comet's output. The The James Webb Space Telescope's August 6th observations using the NIR SPEC instrument remained largely classified, with only technical notes and preliminary comments reaching the public. But what little information did surface hinted at spectral lines that didn't match standard Comet models. Sources close to the analysis teams whispered about anomalous readings that required extended verification procedures. Just as the scientific community prepared for the next wave of discoveries, the information spigot turned off. August became September, and September stretched toward October, with nothing but silence from the world's most advanced observatories. The last official images, released on September 5th, showed a comet that was clearly evolving and developing features that demanded immediate follow-up. But follow-up never came. Instead, NASA retreated behind technical explanations about solar geometry and safety protocols, leaving the global astronomy community staring at the same old images, while one of the most important discoveries in human history continued its journey through our solar system, unwatched by the very instruments designed to unlock its secrets. NASA wants you to believe their silence is purely technical. According to official statements, both Hubble and the James Webb Space Telescope are bound by strict solar avoidance rules that automatically prevent observations when a target gets too close to the sun. Hubble maintains a 50-degree safety margin, while JWST requires an even stricter 85-degree separation. As 3I Atlas continued its journey, it allegedly crossed these boundaries, forcing both telescopes into an unavoidable blackout. On the surface, this explanation sounds reasonable. These are incredibly sensitive instruments, and direct sunlight could permanently damage their delicate detectors. The keep-out zones are hardwired into the mission planning software, with automatic safing protocols that can't be overridden even for targets of opportunity. NASA emphasizes these aren't bureaucratic decisions, but hard physical limits designed to protect billion-dollar investments. But here's where their story starts falling apart. The timing is too convenient, too perfectly orchestrated. 3I Atlas didn't just gradually drift into the danger zone, it hit both telescope limits at the exact moment when the most intriguing discoveries were being made. Hubble lost access in late August, right after capturing those anomalous brightness variations. JWST went dark just days after its NIRS-PEC observations, before any detailed analysis could be released. Even more suspicious is the contrast with NASA's response to previous interstellar visitors. When Oumuamua appeared in 2017, the agency moved heaven and earth to maximize observation time. Emergency scheduling sessions were called, regular science programs were interrupted, and every available instrument was redirected to capture data before the object disappeared. The same urgency drove observations of Borisov in 2019, with rapid-fire releases and real-time updates. But for 3I Atlas, supposedly the most scientifically valuable interstellar object ever detected, NASA's response has been bureaucratic inaction. No emergency protocols, no special scheduling exceptions, no attempts to coordinate with international partners to fill the observational gap. Just a shrug and a reference to safety protocols that somehow didn't prevent extensive observations of equally challenging targets in the past. The agency's communication strategy raises even more red flags. Previous blackouts, when they occurred, were accompanied by detailed technical briefings explaining the constraints and providing alternative observation schedules. Scientists and the public were kept informed about when coverage would resume and what instruments might still be available. For 3I Atlas, those briefings never materialized. Instead, NASA offered vague references to solar geometry and unexplained delays in data processing pipelines. Standard observations that typically required weeks for analysis and release suddenly needed months of verification. Preliminary results that normally appeared within days vanished into extended review processes with no clear endpoints. Even routine technical parameters that posed no security concerns disappeared from public databases. The European Space Agency's parallel observations tell a different story. Ground-based telescopes and orbital platforms, operated by ESA partners, continued tracking 3I Atlas well into September, capturing images and spectra that should have complemented NASA's flagship observations. But coordination between agencies, normally seamless for major astronomical events, became strangely fragmented. Joint press releases stopped appearing. Collaborative data sharing, standard practice for interstellar visitors, quietly ended. Perhaps most damning is NASA's response to direct questions about the blackout. When pressed by journalists and scientists, agency spokespeople offered the same scripted answers about technical constraints and safety protocols. But when asked about specific alternative observation strategies or international cooperation opportunities, those same spokespeople suddenly became unavailable, or referred questions to higher authorities who never responded. The silence isn't just about missing data anymore. It's about a systematic breakdown in the transparency that has defined NASA's approach to space science for decades. Something about 3I Atlas has the agency scared enough to abandon its own principles, and their official explanations are falling apart under scrutiny. While NASA maintained its wall of silence, one of the world's most respected astrophysicists was quietly reaching conclusions that would shake the foundations of everything we thought we knew about 3I Atlas. Dr. Avi Loeb, Harvard professor and former chair of the astronomy department, began publishing analysis that read like science fiction, but was grounded in hard mathematical reality. Loeb's initial assessment was measured but disturbing. The object's trajectory, size, and behavior patterns didn't match any known comet classification. Standard models for interstellar objects predict specific orbital characteristics based on gravitational interactions with nearby star systems. 3I Atlas was following a path that seemed almost deliberately calculated, not random. The trajectory analysis revealed the most unsettling details. Unlike previous interstellar visitors that followed predictable hyperbolic orbits, 3I Atlas appeared to be making subtle course corrections. These weren't the random perturbations caused by outgassing or solar wind pressure. They were systematic adjustments that suggested some form of guidance system. When Loeb's team ran the numbers, they found that the object's current path would bring it remarkably close to Earth in late November or early December 2025. But Loeb went further than trajectory analysis. He examined the object's physical properties and found anomalies that challenged basic assumptions about comet composition. The mass estimates derived from gravitational perturbations suggested 3I Atlas was far denser than any known comet, potentially exceeding 33 billion tons, despite its relatively small size. This density approached values seen in metallic asteroids or artificial structures, not the ice and rock mixture expected from interstellar comets. The lack of a visible tail became another critical piece of evidence. Every previous comet observed at 3I Atlas's distance from the Sun had developed extensive tail structures from solar heating, but high-resolution images showed minimal tail development, despite clear signs of coma activity. This suggested either an unusual composition or some mechanism that was containing or redirecting the typical outgassing process. Loeb's most controversial hypothesis emerged from combining these observations with historical patterns of interstellar visitation. 3 confirmed interstellar objects in less than a decade suggested these events weren't random cosmic accidents, but potentially part of a larger pattern. If advanced civilizations existed elsewhere in the galaxy, reconnaissance missions to investigate developing technological species would be a logical strategy. The evidence against 3I Atlas being a natural comet wasn't just theoretical speculation. It was mounting through direct observation of behaviors that defied every known model of comet physics. Each anomaly, taken individually, might be explained away as unusual but natural phenomena. Combined, they painted a picture of something that operated according to principles unknown to natural science. The mass-to-size ratio represented the most fundamental violation of comet physics. Standard models predict that interstellar comets should be primarily composed of water ice, frozen gases, and rocky material, giving them densities between 0.5 and 1.5 grams per cubic centimeter. But gravitational analysis of 3I Atlas suggested a density approaching 3 grams per cubic centimeter, more consistent with metallic composition or some form of engineered structure. This density anomaly became even more disturbing when combined with the object's lack of typical comet behavior. Natural comets at this distance from the Sun should be experiencing massive outgassing as solar radiation heats their surface ice. The expected result would be dramatic tail development, rapidly decreasing mass, and predictable changes in orbital velocity from rocket-like gas emissions. 3I Atlas showed minimal tail development despite clear signs of surface activity. The chemical signatures detected by spectroscopic analysis revealed another layer of impossibility. That carbon dioxide dominance wasn't just unusual for comets at this solar distance, it was chemically unstable. CO2 ice sublimates at temperatures much lower than water ice, meaning any natural comet with high carbon dioxide content should have lost most of it during its journey through interstellar space. The presence of abundant CO2 suggested either recent formation or some mechanism for preserving volatiles that doesn't exist in natural objects. Thermal analysis provided additional evidence of artificial systems. Infrared observations showed heat signatures that didn't correlate with visible surface features or solar heating patterns. Natural comets produce predictable thermal emissions based on their composition and solar flux. 3I Atlas was generating thermal signatures that suggested internal heat sources or surface materials with engineered thermal properties. The electromagnetic anomalies detected by radio telescopes raised the most disturbing questions. Natural comets can produce radio emissions through plasma interactions with the solar wind, but these are typically random, broadband signals. The structured patterns detected from 3I Atlas's direction showed timing regularities that suggested information transmission rather than natural electromagnetic phenomena. The institutional response to 3I Atlas reveals a carefully orchestrated information management campaign that began the moment the object's true nature became apparent. By reconstructing the timeline of decisions, classifications, and communication breakdowns, a pattern emerges that suggests coordination across multiple agencies and international partners to suppress public awareness of what may be humanity's first confirmed alien contact. The cover-up began subtly in early August when routine data-sharing protocols suddenly required additional security reviews. Standard astronomical observations, typically available in public archives within days, began experiencing unexplained processing delays. Initial reports described these as technical issues with calibration software, but the delays affected only observations related to 3I Atlas, while other targets continued normal processing schedules. By mid-August, the classification creep became impossible to ignore. Orbital parameters that had been publicly available since the object's discovery were quietly moved to restricted databases. International collaboration agreements that normally facilitated automatic data sharing required special approvals that never materialized. Even basic photometry data from ground-based observatories began disappearing from public access points. The Mars flyby opportunity on October 3rd should have been a breakthrough moment for gathering additional data during the observation blackout. Mars Reconnaissance Orbiter and the European Space Agency's Trace Gas Orbiter were perfectly positioned to observe 3I Atlas during its close approach, but instead of preparing for intensive observations, both agencies cited technical constraints and scheduling conflicts that prevented meaningful data collection. This represented a complete departure from standard operating procedures. Previous interstellar visitors had triggered coordinated observation campaigns involving every available asset. The 2017 Oumuamua flyby saw unprecedented cooperation between NASA, ESA, and international partners to maximize data collection before the object disappeared. But for 3I Atlas, potentially the most important interstellar visitor in human history, the response was bureaucratic paralysis. The information management extended beyond just withholding data. Active disinformation campaigns began appearing across social media and scientific forums, dismissing legitimate questions about the observation blackout and promoting explanations that didn't match the technical realities. These weren't organic discussions, but coordinated messaging that consistently diverted attention from the most disturbing anomalies. Academic institutions found themselves under subtle pressure to avoid 3I Atlas research. Grant applications mentioning the object encountered unusual delays and additional review requirements. Conference presentations on interstellar visitor analysis were quietly redirected to less visible forums. Researchers who had built careers studying comets and asteroids suddenly found their 3I Atlas work classified or subject to export control restrictions. The international cooperation breakdown was particularly revealing. ESA, normally eager to showcase European space science capabilities, stopped promoting their 3I Atlas observations. Japanese and Canadian space agencies, usually vocal participants in major astronomical discoveries, went silent. The typical flood of press releases and public engagement activities simply evaporated across all major space agencies simultaneously. Media management became increasingly sophisticated as public interest grew. Science journalists found their usual sources unavailable or providing only scripted responses. Press conferences that would normally accompany major discoveries were canceled or postponed indefinitely. Even routine technical briefings that kept the space science community informed disappeared from institutional calendars. The trajectory of 3I Atlas points toward a convergence of events in late 2025 that could determine humanity's immediate future. Based on current orbital calculations and the behavioral patterns observed before NASA's information blackout, several scenarios are developing simultaneously, each with profound implications for how this cosmic mystery resolves. The December emergence represents the first critical juncture. as 3I Atlas completes its solar passage and moves into positions where flagship telescopes can resume observations. The object's post-perihelion state will reveal whether it survived solar heating as a natural comet or continued operating as an artificial system. Natural comets often fragment or significantly alter their activity patterns after close solar encounters. If 3I Atlas emerges essentially unchanged, it would provide strong evidence for Loeb's artificial hypothesis. The timing of this emergence coincides perfectly with what Loeb has calculated as an optimal Earth approach window. If the object continues its current trajectory modifications, it could achieve close approach to our planet in late November or early December 2025. This wouldn't be a collision course, but close enough for detailed reconnaissance or even communication attempts if the object indeed harbors intelligence. Ground-based observation networks are already preparing for this possibility. Amateur astronomers and independent research groups have coordinated to maintain continuous monitoring during the December emergence, recognizing that institutional sources may continue their information blackout. This distributed observation strategy could provide the first reliable data about 3I Atlas's post-solar condition, regardless of official agency responses. The implications of confirmed artificial nature would trigger consequences that extend far beyond scientific discovery. International protocols for potential alien contact exist only in theoretical form, never tested by actual events. The United Nations Office for Outer Space Affairs has drafted guidelines for extraterrestrial intelligence encounters, but these assume cooperative first contact scenarios rather than potentially reconnaissance or threat assessment situations. The technological implications could revolutionize human capabilities if any form of meaningful analysis becomes possible. Even passive observation of an artificial interstellar object could provide insights into propulsion technologies, materials science, and information systems centuries or millennia ahead of current human development. The question is whether humanity would be allowed such access or if the object's intelligence would prevent detailed study. Communication attempts represent another developing scenario. If 3I Atlas shows signs of active intelligence during its December emergence, various groups are preparing transmission attempts using radio telescopes and optical signaling systems. These efforts range from scientific institutions following established SETI protocols to independent groups with their own communication strategies. The potential for a coordinated response depends heavily on whether institutional suppression continues or gives way to open scientific investigation. If agencies maintain their information blackout through the December emergence, it could trigger a crisis of confidence in governmental handling of existential discoveries. Public pressure for transparency may force disclosure regardless of institutional preferences. Longer-term implications stretch into 2026 and beyond. If 3I Atlas completes its solar system reconnaissance and departs, humanity would be left knowing that we're under observation by intelligences with capabilities we can't match. This knowledge would fundamentally alter human perspectives on our cosmic isolation and potential future interactions with alien civilizations. Alternatively, if the object establishes some form of ongoing presence or communication, it would represent the beginning of a new era in human history. The transition from a single-species planet to participants in a larger galactic community would bring challenges and opportunities that current human institutions are completely unprepared to handle. The next few months will determine whether 3I Atlas remains a scientific curiosity or becomes the catalyst for humanity's first confirmed alien encounter. Either way, the cosmic silence that has surrounded our species for millennia is about to be broken, and the universe will never look the same again. The countdown to December has begun, and with it, the possibility that everything we thought we knew about our place in the cosmos is about to change forever.